All right. Hello, everyone, and welcome to Handmade Hero. This is the stream where we code a complete game live here on Twitch. Here's the thing. I believe yesterday I was just about to finish cleaning up some code, and I didn't really get a chance to do it, so we're just going to dive right back into that. We were sort of cleaning up our debug layer so that we can call it done and kind of put the stamp of approval on it for use in the game. And so I've got some things that I want to do to make that happen, and so we're going to finish doing those. If you are trying to follow along at home, today is day 250. Not quite at day 255 yet. Obviously, when we get to day 255, we're going to wrap or back around to day 0 because we only have a byte counter. Just kidding, that's not actually true, but it would be funny if it was. Anyway, day 250, you want to unpack day 249 source code if you're following along with the source code at home, because that's what I'm going to start with today. So if you're trying to follow the stream on your own, start there. So let's take a look at where we ended up. If you remember correctly, at the end of last night's stream, I turned off the debug system because I didn't want to leave the checked-in code in a broken state for anybody. So right now, we're not actually seeing any debug output on the screen at all. We're just seeing the regular game start up as it normally would with the cutscene sequence and all that sort of stuff, right? So what we want to do now is we want to go ahead and get back to that sort of debugging. Well, it wasn't debugging. It was actually just us. Oh, we don't need Emacs anymore. I always forget. It's like force of habit. We need to get back to getting our stuff compiling because we changed around how the macros were going to work on our debug layer. And so we need to finish that up. So here we go. Let's load up our project. And let's build. There we go. And so if I load our build.bat file, it was this part right here, right, handmade internal. That's our debug switch, and you can see that I've switched it off. If I switch it back to on, we will go back to getting, I assume, or not. I figured we would have got compiler errors on that, but I guess not. There we go. I don't know what happened there. That was weird. All right, I won't ask. Anyway, when I compile now, we're back to getting compile errors, and so what we have to do now is we have to go through and fix the compile errors that we got from changing the way that we do our debug output. And I believe what we decided to do here was we updated how debug data block works, and that's in debug interface. You can kind of see debug data block right here is one of these things. All it typically gets passed is the name, whatever the name of the data block is actually supposed to be, and that's all it is. So I don't know. Like I said, we sort of got rid of the concept of having a debug ID beyond that. It's just that one name pointer that gets used. So I don't know, maybe that'll be a bad decision. I don't think it particularly will be. I think it's probably going to be okay. But what that means is at this point we can sort of get rid of this concept here in its entirety. And the entity debug ID, which we had up here, was previously just being used for this debug hit stuff, which is basically what lets you say whether or not you were going to request that thing. And that can stay in, right? So the thing that actually works for that totally is fine. And if we wanted to, we could associate this data block with that entity debug ID in the future by having some way of specifying that as a value. Like we could, if we wanted to, include this in here. Entity debug ID. 4Coder has its expansion for some reason doesn't pick things that are nearby to the cursor yet. So it's kind of hard to use the auto expand. It doesn't work like it used to in Emacs. So it tends to be pretty tough. I'm not sure how it actually decides that. But anyway, so that's why I kind of got to cycle through that. But anyway, we could do something like that in the future. So I'll just say, do we want this? And I don't know if we'll have much of a reason to use that or not. But it's our prerogative if we want to. I don't know. So anyway, that's how that works. And what's the problem here? This is supposed to be a string. So this is like simulation entity. Oops. Going to switch to the slash for pass syntax in case I want underscores. I figured I should pick something that isn't a valid identifier name. So yeah. And now we got to fix the debug system because we removed some of these things like name, event, block name. For now, I think what we want to do here is just let this be the GUID for now, but in the future we're going to want to parse that GUID out and actually do some stuff with it. So we'll leave that for now. Open data block, I don't know that we actually want any of this here. I think I might just say that that's not going to get printed out at all, because we decided to stop printing those anyway, and they're handled kind of differently in the external code anyway. And so I think we're just going to leave that like that. Here I'll put that GUID again if we need to, and just in case for debugging purposes. And I think that should basically be it. So let's see. So we've got that. Now we've got get group for hierarchical name. If we are to pass the block name in here, if we pass the GUID in there, we'll have to do some work inside there to sort of first find the end of it, right? Because the way that we're building these now is a little bit different, right? We've got Handmade debug interface is building these potentially using the debug name thing. And speaking of that, is there a reason? Do we know why we didn't do the debug name here? I feel like that's a screw up. Like, I feel like we want this to really be that, right? Because why wouldn't we do that, right? It only gives us more information, and the name is preserved when it's passed through, so we can still parse it out. So I think we're pretty much always going to want to do that, if I'm not mistaken. All names that come through the system, I think we would probably want to first do a debug name on them so that we just have that information about where it came from. So I would say almost all of these are probably that way, right? When we do any of these things, because record debug event, I don't think will automatically do it, right? Record debug event doesn't try to do anything automatic. It just takes it directly as it is. You can kind of see that. So I think in all these cases, what we really want to do is we want to make sure that we're always passing that debug name, because that's the thing that will wrap whatever we say into a string that's got the additional information. So I think that's what we want. We can obviously always bail on that if it turns out that I'm doing something stupid, and that's not a good idea. But that feels to me like the right thing, because that way we're essentially packing all of the important information into one pointer. It just has a string that's just got all of that in it, and that way the debug system at its leisure later can just kind of extract that as necessary, which seems reasonable to me. Yeah, we're going to have a little bit of work to do, obviously, later on, where we have to kind of deal with these strings. That's going to be a separate issue, but anyway. So, all right, that seems fine to me. Let's see what we've got here. Block name. So this matching block name stuff is just going to match the GUID. That's pretty straightforward, right? What else we got here? Block name. Yeah, I don't know that there's really a lot of cases where we can't just swap block name. Where we can't just swap block name with that code, and then later we just got to kind of parse it out and make it into something more reasonable. So anyway, we're now in the time block, and so we got to go ahead and fix our time block stuff. So here is time block. Not sure what the complaint is there. It looks like our unwrapping macro was not working properly. It looks like it's not welding, maybe, the way that it should. Because this is the first time that we've got two time blocks, I guess. Or is that just the first time block? What does it say? Time block underscore. So it's not actually welding a number on there. So that just looks like a macro bug. It's not welding this number, right? So why isn't it welding that number? Well, if we say time block name, it looks like it's not welding the number because we accidentally eliminated that, which is stupid. So that's not a good idea. So let's not do that, and then we should be fine. Okay, so missing a close before identifier pixel fill. Again, this is probably just a problem with the macro. So pixel fill is going to come out right here. Where is debug name function and debug name name? That needs to be a string. Am I right about that? So yeah, let's take a look at at that particular guy. Where is it? There we go. So I think the only problem here is that that's supposed to be a string, and it wasn't a string. Other than that, I think we're fine. Ignored time block. I don't know what an ignored time block was supposed to be. So I guess these are not really so ignored, if I may. So that's fine. I mean, there's nothing wrong with that, but... All right, so ignored time block. Pixel fill just needs to, again, be like this. Let's see what else we got here. These guys don't need to be there anymore. And debug data block, platform / controls. You know, I don't know why that happens. Also, there's a weird vocoder thing where it loses the compilation directory periodically. I gotta see what I'm doing wrong there, because that must be something I'm doing since I'm the one who stores the compilation directory. So I must have a bug in my vocoder config, but I don't actually know what the bug is. I gotta look into it, because I'm actually the person who stores that, and it gets... I must like accidentally hit a key that overwrites it, that I bound to something. I don't know, it's weird. I messed something up. Anyway, so let's see, executable refresh. So this is begin block now. Again, I think this is just going to be a situation where this is actually a word now, where we don't have to, yeah, so that's really, there's not particularly much. Wait, why does end block need a name? That doesn't really make any sense, does it? Do they match by name? Is that how we did that? Because I assume that they... Like, what is the idea behind that? Does anyone know? In fact, end block is not supposed to even have to take a name anymore. Yeah, I don't know what the point of that is. I'm just going to delete that, and then we'll see if that actually matters. Because the blocks have to open and close symmetrically. It's not like you can open one block, close a different block, and then close that block. I don't think we allow that. Or at least if we do, I think it's fine to disallow it, because I don't really feel like putting that in there, you know? So yeah, so let's go ahead and get rid of that, because I don't even know what the point of that is. It should just always close the surrounding block. And I suppose what we could do is we could make this be a begin block, end block. We could just use timed block for this pair and have it pass the string twice if we wanted to do that. We could do that. I don't know that we care that much about it. We'll see. All right. Oh wait, I don't need that. Why am I doing that? I just said I didn't want that. Or that. There we go. And let's see. Okay. So now I don't actually know if we should probably have, we didn't really go finish the debug layer to change it to support the things that we did. So we are kind of not quite there yet. But we're already, you know, working to a certain degree, as you can kind of see. We have like, we have some stuff doing some stuff. The problem is that right now what it's doing is it's taking every debug event, and like I said, since we're not parsing this extra information that we get and stripping it off before we do any of our other debug work, we just end up in this circumstance where we've got all kinds of garbage in here, because each one of our this is like, there's going to be one of these for every line of debug code, because hey, our GUID is working, good news. It's got the file line and counter and all that stuff. So it means that we have a unique source for every last piece of debug code in our game, but that's not how we want to actually display it. So basically what we need to do now is just ping back over to the debug code, and when these GUIDs come in, we want to parse them out so that we grab the file line and counter information from them, which is all good. But we want to strip that part off and save it, and then just use that that other part, which is sort of the real name that we gave it, parse that and use that to construct the debug hierarchy as necessary. So that's what we need to switch over to doing now. I think, don't quote me on this, but I think we're at the point where where the macros are a little saner. So anyway, I'm pretty sure we also tested this. We'll have to test this again. As you know, this is the debug space remaining. And so when this gets down to 0 is when debug information starts getting recycled. After we're done with all this, since we've made so many changes, we should set the total debug arena down to a really small size, like 1K or something, so that we can watch it recycle a lot and make sure that we don't have a bug in there. Because obviously, even though we tested it a while back, we're not really testing it now, because until that number gets to 0, no recycling is happening. So until that number gets to 0, we have no idea what's actually happening in the recycling. The recycling might be totally broken because it's never getting run, right? And so that's also just something to note. Until this number reads 0, we have not tested the recycling in sort of the new stuff. All right, so let's take a look at where we're at in the debug system. So I need to take a moment to refamiliarize myself with sort of what we had here, because we've pulled some things out and sort of reorganized things a little bit. And so I kind of want to make sure that we don't have too much vestigial remains at the outset here. I kind of want to trim away potentially a little bit of that as necessary, and we'll see how we go. So I'm just going to start at the beginning and just take a quick look at how we ended up in terms of our structures here. You can see that the debug state is pretty giant here. Yeah, at the risk of stating the obvious. So we've got a lot of stuff in here. We have the high priority queue, and I believe the only reason we have that at all is because this needs to be able to display font information and other bitmap debug data. So it needs to be able to talk to the asset system and load stuff. So I suspect that's why that's there. But again, since I'm just refamiliarizing myself, I'm just gonna make sure that I actually know that that's true for reals. So I'm gonna go and search this file and just say, okay, where is high priority queue actually used? Looks like the answer is nowhere. So let's take a brief look and see if we even need that anymore. We might not. Looks like we don't. So if the high priority queue is not needed anymore, I'm just going to vape it. Because, yeah, since we're talking to the asset system, I'm assuming that that's... Yeah. You know what that was? It was for when we actually called the renderer in here, probably. But we don't anymore. We just build the command queue and let it deal with it later. So I think it's probably fine, because the render group is going to have access to that. I mean, at least I assume. So anyway, let's go back to what we're looking at here. So we've got our arenas here. We've got our initialize. That stuff's fine. Our render groups, our fonts, which we need. We don't really need the compiler anymore, because we don't ever run the compiler from the debugger anymore. So that actually could go away. And we could, if we wanted to, pull that stuff out of the platform layer and just say we don't do that anymore. Because since we don't actually need it for anything, as far as I know, we could just vape that. Maybe we should. And we can leave it in the platform layer for now. We can say that that's going to stay in the platform layer for now, just in case we want to turn it back on. We won't delete the important part of the code, but might as well get rid of that for now. So we've got menus and selections and that sort of stuff. And then we've got our hash tables here for elements and information about elements. The root groups and the trees. That's what I want to take a little bit more of a look at first. First, I'm going to just go through here and just check this stuff out. Scope to record. I believe that was a thing we were using for profiling. I'm going to get rid of that temporarily and see, because I wanted to know, is that just that actually is part of the collation work? I'll leave that in there temporarily, but that probably we want to reassess as well as we do the profiling, as we do a profile view. All right, so oldest frame, most recent frame, and collation frame. I don't really remember very much about these frames, to be honest with you. So I'm going to take a look at struct debug frame just to see what's here. So yeah. So these are just in max regions per frame. Is that even a thing? Do we even do any of this stuff anymore? To what extent do we use these? I'm interested to know. So let's take a look. Let's look at collation frame. Is that even being used anywhere? There it is. So when we do this, we create a frame and we're collating that frame. And then I guess when we're done with that frame, we push it on that set of frames. So that's fine. I don't really know what we do. I guess that's just kind of sitting there waiting for us to put more information in it. Because if you take a look at it, right, there's nothing really in here. It's pretty minimal information. It's just when the frame began and ended, how much time elapsed between those two, and then some information that you might have used if you were displaying like other stuff. So I feel like, yeah, that's not super important. Interesting. Anyway, doesn't matter. So anyway, yeah. So we got the frame information there. We've got this stuff, which is really only used during collation. We could probably pull this out into a separate thing, so it was clearer that it was only used during collation. But this is how we sort of build up our collation stuff. And then we've got sort of our free lists here just for some memory management purposes. But that's about it. So, all right, that all seems fine for now. What I'm interested in looking at in a little more detail here is this the element tree view, all that stuff. Because I kind of don't really know much about how this is supposed to work, right? And we went through a couple different revisions of it, and so we kind of never quite settled it down into exactly what we wanted for sure. And we're closer to understanding what we want now, so now I think would be a good time to massage that down, just kind of polish it out, and make sure that it's working in a reasonable fashion. So we have 4 things here, in addition to debug events. Debug events are the things that go into the buffers that we actually look at, that actually capture some important piece of data. But then we've got 4 more things. We've got a debug element, a debug view, a debug variable group, and a debug tree. And I feel like that's just too much stuff. My hunch is that, you know, I wanted to do explorations to see how much stuff we could do, and maybe we want to cut a feature or two that we don't super care about necessarily, and make try to get that feature in a different way so that we don't have to worry about some of the things. So for example, one of the things that I was playing around with was the ability to tear off, I don't know if you remember this, like you could tear off a variable and view it. I don't know if we still have, I don't know if we actually still have that at all, but I think you could like write tear off something. I don't really remember how it worked. It was some weird thing that you could do. Yeah, I have no idea. But we had some weird thing a while back where you could tear off things and place them. And I don't think we really need that. I think that was an interesting thing to look at, but it was probably just not that necessary. Because what I was thinking, and I don't know why I didn't think of this before, but what I was thinking is if you want to build, you know, easier access things, we don't really need that to be so dynamic. Right? We can still just have one debug view tree, and then we can just have different like trees that it could view that we just set which one it is in the program and be done with it. We don't need the ability to really like dynamically customize those at runtime or do anything else too ridiculous there. So I'm not sure that we really need to do it that way, but either way, you know, we may want to keep the concept around anyway, because we probably do want multiple views into the data so that we can like have optimized views for different types of debugging. Like when we're trying to debug memory, we can set it up for one way, and when we're trying to debug, you know, performance, we set it up a different way, or who knows what, right? So let's just try to drill into these a little bit. So I'm just going to go take a look at what each of those is and what it's supposed to do. So you can see the debug views here. And debug views are just all a debug view is, and this is something that I don't think really needs to be edited much. All a debug view is a way to give some information that attaches to a piece of debugging state that says like how to view it, right? Because what's happening is we've got these debug events, and they're sort of coming in. These debug events are like coming in through the system. We're recording them all, right? And we wanted some way of saying, oh, when I'm looking at one of these, I want to attach some information to it that'll let me know what to do when I debug. And so they were set up so that we could sort of look at them up by debug ID or whatever, and that would give us the information that we needed to know about what should be happening in that case. And the reason that we did that by hash was so that we could have it be sparse and basically be like, if you interacted with something, then we'll remember it. But if you've never interacted with it, then we don't really need to ever remember it. So that way we could view things like giant lists of things without having to really worry too much about them, right? So I don't know how necessary that is, but there's nothing wrong with that system. Seems totally fine. So I don't know that we need to do anything too much more complicated with it. We can just leave that as it is at the moment. So let's move on here. So we have debug stored event. Debug stored event is how we take information out of our debug buffers and keep it around permanently. Those are the things that we're sort of filling up that per frame arena storage as it kind of goes up. That's what's storing it is this thing, this debug stored event. Our debug element, a debug element is a sort of the header that says, this is a particular source of debug information in the program, and it's got some number of stored events that have happened to it over time, and they're stored here. So this right here is basically a linked list of all of the events that occurred from this particular element, right? Then we have this, which is a hierarchical way of viewing the data, right? You can link this up to children. And then finally we have debug trees, and debug trees are just one of those the notion that we would start at some variable group, which is the hierarchical thing, and display it somewhere on the screen, right? So honestly, as much as I'd like to say that it's a little overwrought, honestly, I think we've represented actually each thing we do really need to have in here. Like, none of those are particularly redundant. You could collapse some of them down onto each other if you wanted to lose a feature. Like, for example, we could collapse the concept of a debug view. We could just collapse that into the debug variable link itself. That probably would work fine. But if we did that, then different debug trees would not be able to have different states. So for example, if we had two debug trees that both included somewhere in them a particular collapsible group, when we expanded the group, it would be expanded in both. So you can see why, you might not want to do that reduction, because you definitely lose a feature. So I'm not sure that any of these are actually completely redundant. So it seems fine to me that we actually have them. So really, all I think we need to focus on for the time being, in order to get things to a state that's useful to us at the moment, is that the debug element, the debug elements that we're building, these GUIDs are now those full names that have a bunch of information in them. And I think what we probably want to do is parcel out that information into something that's actually going to be more human usable, right? So you saw how it was going there. We want just that last part to be constructing like the hierarchy for us. We want to parse out the file name and the line number in a different way or whatever. So what we could do is say that when we encounter a debug event, we will create a debug element that sort of has that information in it. So we'll have, the file name that it came from, the function name that it came from, perhaps, and the line number in that file, right? We can have that information, and then we can have its actual name. All of that stuff we can actually have known, right? All of that stuff seems totally totally doable. So when we get to one, we parse it out and we put it in that format. That way our debug elements actually kind of have that information blown out, and people can use the one they actually want to use, right? So let's just start there, because I know that I want to do that, so we might as well do that. All right. So when we're doing this and we're looking to see if we can match, instead of matching these GUIDs, we don't want to do that anymore anyway. That's just not a good idea, right? In fact, when I'm looking at this, what we probably want to do is just take it a little slower, actually hash the string value, right? Because if we want this to work across hot loading, we have to be able to allow the GUIDs to change pointer, right? We can't count on the GUIDs always being the same pointer, because across hot loads of the game code, all of those pointers are going to change. So well, not necessarily all of them, but some of them probably are going to change, possibly all of them, but certainly some of them are going to change. So what we want to do here is we want to have some way of actually hashing this stably, I think. So I think what we want to do here is do a string hash, right? So we always do exactly what I said we always need to do, right? And you remember this. We need to do this right here, better hash function. You always put it to do in front of your hash function, says better hash function. Then you write a really bad hash function, and then you ship it. That is how everything always happens. It's a requirement if you're going to be a professional programmer. You need to know how to do this. Because, you know, hey, you put it to do there. So the fact that you'd use an awful hash function, you're absolved of all guilt, right? I mean, what's the problem? So here's my scan function. I'm going to take a look at the GUID as it comes in. So the event has that GUID that's coming in. I'm going to look through the string here, and I'm going to start with a hash value of 0. I'm going to go ahead and you know what we could do? And I'm loath to even do this because I'm teaching you the wrong thing, I suppose. But if we were to type in good string hash, right? We could take a look to see if there's any particularly good hash functions here. Hey, look, it's the University of Washington, which is, you know, actually pretty good for CS, right? You can see here. They've got a whole slide presentation on it. Making streams fast. Use Horner's rule. This doesn't look... I'm not so confident in that. Hash functions for strings. Let's see here. Let's see here. What have we got for hash functions for strings? Because we could take a look and see if there were good hashes for strings. Here we go. So here is an example of a string hash, right? Not particularly good looking. Maybe it is good, I don't know. But you can kind of see what tends to happen with these guys. You do some math ops on the thing as you go, and that supposedly gives you better string hashing. I don't know. I'm not going to do it. I don't know anything about hashing. If that's number theory, and I'm zero knowledge of number theory. So we are just going to use the world's worst hash value for strings, which is to just use the sum of the values. And we'll just let the chat, people on the chat, there'll be somebody who's more into number 3 on the chat, maybe pseudonym 73 will know. And then he can say, maybe multiply the values by this as you mix them together, and then it'll be better. And then we can go back to it. But I don't really want to do that now because I don't know. So anyway, so once we get a reasonable hash value and we pretend that somebody else did that for us, obviously we do the same thing that we always do. It's trivial to get an index from that. We just say, all right, let's go ahead and mod that value so that we know that we're inside the array, and then we can search through here to see if we get any matches for that string. Now, when we take a look at that string, we're no longer going to be able to just check these two. We have to actually do a string compare, but we can do a string compare on some of the other values probably a little more easily, if that makes sense. Although, well, no, I'm a little torn here. So if we just do one string compare, then that makes it a little bit quicker. I suppose, than having to do multiple of them. I don't know. But what I was thinking of doing, and maybe this is a bad idea, is I was thinking of saying like, oh, okay, maybe what I actually want here is debug element source. And debug element source has that in it, right? And that way what I can do is I can just say like, oh, okay, when you actually send me one of these things, for whatever it is, the debug event, I'm gonna actually assume that after we do the hash of the GUID, we're gonna store it in here, but then we're gonna want to parse it out, right? So we're going to want to do the parse of this debug element source into its separate pieces so that we actually can compare them, which we would not have otherwise been able to do, right? So that makes it a little bit trickier. That's why I say it's a little bit iffy. I also don't know, we don't actually get the function name, do we? That's sometimes passed, so it's really just this is all we have, right? So maybe what I actually would need to do, again, just trying to think through how this is actually going to work out, maybe I do still want to keep the GUID there, and then I would want to do something like say, well, you know, we've got the GUID, and then what we do with the GUID afterwards is we just parse it. Maybe we keep sort of like a pointer into it that we can use, like something like, you know, file name count * file name, something like this, right? Since we know that we have to sort of extract it, and then like this. So we'd still just keep one buffer, and then we just keep pointers into it to sort of say where those things were. I don't know if that's a great idea or not, but that's what I'm thinking. So anyway, this way, if we do, the reason I was thinking we do that way is because then if we keep the GUID, then I can at least just do like strings are equal to each other, and then I can say like if the GUIDs are equal to each other as strings, then this is the one. If not, then it's not. And so then here we would go, and we'd get that information out, right? And so if we get, excuse me, if we get to the point where we need to allocate a new one, then what I would want to do is I'd want to use sort of the debug memory to store these GUIDs. Like before, we weren't storing the GUIDs, we weren't sort of pushing them onto our debug memory. And that to me is like a bad idea because like I said, during reload, you know, we would crash occasionally there where we would be using, because the debug system was not safe across hot loading. So if we tried to hot load, we could crash the debug system. And I don't want to do that. I want the final debug system to be able to work across reloads so that when you're doing hot reloading, you can use the debug system. I mean, we want those two systems to work together. So what I want to be able to do here is I want to be able to push that string onto some permanent storage. And, you know, inside Handmade debug.h, we have an arena for permanent storage that we can use because we've got the per frame one, but we also got the debug arena one. And so what I was hoping is that we could say, well, the debug state debug arena, you know, can we just push that string on there? So this way now we would always use that result GUID instead. And now we can sort of do that parsing out that I was talking about before. So then we have the next in hash part. All that stuff is going to be exactly the same. This is all exactly the same. The only difference now is we're going to be passing event name through here, and that's going to be what's used for the hierarchical name stuff. And so all we have to do to get this working properly is do the parse of the name so that we can extract the that sort of additional info that we need for like the file name and the line number and that stuff. So we just want to make this stuff work now. So the first thing we have is we have the file name. We want to get the file name by just scanning through the string to find where we actually start that open parentheses, close parentheses. So we would just start with our scan again. In fact, you know what we could do? We could also just do it right here. So while we're in the middle of hashing, we're already going through the string once. We could just do it right here. We could say that like, well, we know the file name pointer. In fact, I don't even know why we bothered with the file name pointer. The file name pointer is just the GUID pointer, right? This is right. Those are the same thing. So they're just used in whatever case. You just would use the file name count. So really all we're solving here is the file name count, if that makes sense. And don't ask me why this is an int, because I don't know. So anyway, so the file name count, we just need to start at 0, and then we just got to go till we see that open parenthesis there and the close parenthesis. So we know that we've got those parentheticals, and what we could do, you know, if you had a file name that had a parenthesis in it, this wouldn't work. We don't, so we don't have to care about that. But just so you know, this isn't going to be like a robust parse of this thing. And so we could just look for the first parentheses and say that's the end of the file name, and that's totally fine. Now, in order to do that, we just say if, you know, that's what we see, then file name count equals scan minus the beginning. That's how big it is, right? Really, really straightforward. And I suppose this could also be, might as well just be name starts at, right? That's pretty simple. So anyway, we've got the file name count. That's how long that's going to be. We've got the name starts at. And the way we know where the name starts at is the name starts after the file name. It's got the parentheses, it's got a dot, it's got a number, it's got a colon, right? So when we see that colon, and where's our debug name here? Debug.h, or actually I should say interface. So here it is. We should just make this be the optimal thing for parsing, now that I think about it. So probably what we would actually want is just this. So all we have to do is just say, like, okay, each one of these bars tells us a particular piece of information, right? So every time we hit a bar in this loop, we know that we've got a different one. So first thing will be, it'll be the file name count. The next time we hit a bar, it'll be the line number, right? And then the last time that we hit the bar, actually, I guess technically this is the file name count and the line number. The next time we hit it, we don't care. The next time, and the next time, the last time we hit it, that's the file name. Right? So I think that's what we actually want. The line number we actually have to parse out, right? So that's actually one of these. It's like that. And again, at some point, when we replace the C runtime library, we're going to have to replace this guy. So not a hard one to replace, so I don't really feel bad about calling that. It's not going to be a lot of work for us to replace an ATOI. ATOI is pretty easy. We don't have to parse a floating point number even, so it's especially easier. So that's okay. So that's not a big deal. Anytime we call something from the C runtime library, right, if we presumably at the end of the series want to actually get rid of it entirely, just for fun, anything we call, we kind of want to know what. And I think we call a couple things. We call a couple math functions, printf, ATOI. And so those, if we want to get rid of them, it's just good to know if we're calling something particularly crazy and weird, but we're not. So ATOI is pretty easy. All right, so, and it's the same thing we call in our parser too, right? I don't know, doesn't matter. Point being, it's not a bad function. It's pretty easy to implement, so I don't think we're adding any kind of unnecessary burden on ourselves for that. So anyway, when we do the scan, all we really need to know is, like, this is the, I guess, the pipe count. So the first time we hit one, second time we hit one, and third time we hit one, right? And right now we don't care about the counter value. There's really nothing for us to do with it. And so if we have all of that information, now when we actually get down here, we should be able to just fill out the struct pretty trivially. So we can just go ahead and say, oh, OK. Let's see here. Debug.h. So file name count equals result, line number equals, and result name starts at. So file name count we already have, line number we've got, and name starts at we have, I believe, right? So yeah, and we could also make a little thing here that's just like get name debug element, and that could just be, hey, if you want to get that, and I could do this. There's no actual need for that union, obviously. That way there's basically just a way to get those without you having to actually remember that that's what the work is. We can just say like, oh, yeah. The result of this guy is going to be the element GUID plus name starts at, right? And that'll return this. And this is get file name. That can just return the GUID directly. Although it's technically a counted string, so, you know, you kind of got to say something like, I don't know if we even have that concept of counted strings. Oh, we do. Here in debug variable group, we've got that concept right here. So probably what we would want to do, I would think, is make that a little bit more of a first-class citizen, right? So we'd probably want to do something like saying struct debug string, and that would be like name length, or you know, length and contents, something like this, and or value. And so that way, you know, when you get one of these, you could just get, you know, the file name as a debug string, and it would return it to you that way. So you'd just say like, oh, you know, the result of this is just the elements file name count and the elements value. The element GUID is the value, and then that's it. So that seems reasonable to me. And then this guy from the debug variable group, obviously that could also eventually become a debug string after we, you know, once we care. So yeah, debug element source, that went away. Name starts at, that is supposed to be off the element pointer, obviously. And what's the confusion here? That is not supposed to be there. Not supposed to be there at all. There we go. All right, so let's see. This is obviously just going to be assumed that these can never be, whoop. There we go. That these can never be that long, so we're just going to cast them down, and that's fine. No, wait, how is our ATOI not found? Because it's in, right? I mean, isn't it in here? Maybe I'm missing something. I don't really remember where that is. There we go. I really wish my 5-minute warning window would go away. I can't see anything. Hello? Try that one more time. All right. So, same thing here. Obviously, since these are 64-bit pointers, after we do subtraction on them, they want to stay 64-bit, but we don't really want them to. So push string needs to take the address of the arena. That's all fine. And then this right here actually needs to take get name of the result. All right, so I don't know if this will work. We'll have to step through it and see. First, I'm just going to run it so I can see what the output of it is, and then we'll go from there. All right, so interestingly enough, it looks like part of the parsing is working. So I guess that's a good sign, to some degree anyway. And And so really, I guess if I just use getName when I'm printing these out, yeah, it's kind of interesting. I think this is going to be good soon. I'm thinking by tomorrow this will start to look kind of nice. I'm looking forward to that. All right, so anyway, when we're printing the GUID, we really don't ever want to print the GUID anymore. Like, we're printing the GUID in a bunch of places, and that's just a bad idea, right? So we kind of want that to stop happening entirely. And so, for example, here, we don't want that ever. We want to do, instead of this, we want to do getName on the element. In fact, why is this? What is this doing? So when we do a debug event to text, I guess when we remap, so I gotta look. Store event. How does store event work? So here we go. We go into store event. We take the frame index. We remember the frame index. We copy the event over. So that's just wrong. That is also a problem, right? Because that means that GUID value, that GUID value is going to get copied, and it's going to be wrong. I don't know what this is here for exactly, but all the rest of these aren't pointers, and that's important, right? These two are, and we may have to deal with them separately. But this right here is not going to be safe. And so what we actually want when we do this is we want the resulting element, event, to actually use the GUID from the element, because that's been cloned. And so now that will be safe across reloads, because it's not going to point to a string table that's in a DLL that might go away, right? So that's, yeah, that's obviously a good thing. You know, I kind of thought about just now something that's kind of interesting. I suppose one thing you could do with hot reloading now on 64-bit systems, since you have kind of infinite memory in some sense, as long as you're not touching it. You're not infinite memory, but a lot. You could just load the DLLs and never free them. So you just load a DLL in, and it's got the string table, and you load another DLL in, and it's got another string table, but the old string table is still valid, right? And then if you wanted to, you wouldn't have to ever worry about copying the strings. It's not that big of a deal because you still can't do the stuff that you would have wanted to do, which is compare like two string pointers for equivalence and know that they were pointing the same string, because that doesn't work anymore anyway. But it's kind of interesting. I never thought about that. If you wanted to keep data around from previous runs, for some reason, you just can. Just don't free the library. Because you can load 12 copies of the game code, right? You can load 50, 100 copies of the game code. You can load as many as you want. It don't matter, right? So that's kind of nice. But anyway. So we sort of have a problem here, which is when we're doing this debug print, the event printing, we don't actually have the element, which is where our stuff has been parsed. And so really, when we do debug event to text, I kind of feel like in here, we want to supply the element pointer if possible, right? So you want to do like, you know, optional element or something like that, so that you wouldn't have to keep parsing the debug name all the time for no reason, right? Now, it's not a big deal to parse it all the time. We could just always parse to the last pipe and print that out. It's not like that's that costly or super problematic. But it does just kind of strike me as being not that particularly important. Or we could just store it pre-advanced. That's interesting. So what we could do too is when we do store event, we could just say like, forget that, like, just do this. Now they would always just be the name, right, when we print them out. So that's interesting. That's pretty interesting to me. All right, so I'm going to go ahead and take that one step further. So those slashes there, anytime we were talking about underscores before, we're talking about slashes now, obviously. Gotta remember to change my for-quota config. I forgot to change it. Gotta change it. I'll do that tonight. So yeah, what I want to do here is I want to go ahead and say, all right, that thing that we're talking about start at last underscore, that's really going to be called start at last slash now. You know what I'm saying? And so start at last slash, it's going to look for that. This guy. Yeah. And the other thing we're going to want to do is now when we're parsing for that, which we're doing, we actually want this thing to be this get group particle name, whatever nonsense here. We actually want that to be this. So I'm going to call this first separator, right? So that we don't have to pin it down to an underscore. Grr. There we go, separator. First separator. First, separator. Okay. Okay. So now, I think we're getting closer. We're still not quite there yet, because it's a little confusing as to why these look like they do. So we're not quite, and these are like printing out weirdly, right? So we got more work to do, obviously, but we're at least in better shape. So I think we're in good shape for tomorrow to kind of get displays into a better place. We can also start filling in the profile stuff and think about how we want to do these these things. So let's go ahead and call it for now. So I'm going to go ahead and go to the QA. And leave it at that. Please define hash computation 65599 plus scan. So do we know if that's a good idea? I mean, obviously you want to do something other than summing the values, but I just don't know. How do we know that 65599 is a good idea? I guess you've got a source there. Let's see what it says. I'm gonna look at pseudonym 73's. I trust his math skills, is all. So what he's suggesting is anding out the high 4 bits and then XORing with them shifted down, knotting them. Wow, that's a crazy little, that is a crazy hash. Is there a reasoning behind this hash? Is there reasoning behind why we would pick this hash? An FNV hash. And then someone else is suggesting the 6559 one. So let's take a look at what that one is. Comprehensive collection of hash functions. Oh, hey, look. K&R first edition had to sum them all up. That's so great that it goes all the way back there. I'm just going to 65599 was picked out of thin air while experimenting with different constants and turns out to be prime. This is one of the algorithms used in Berkeley DB and elsewhere. Weird. I feel like somebody should have a more sort of stringent proof of why this is good. I'm gonna look back at the chat. So I guess what I would say is times 6599 is really easy to do. So I feel like if we were always going to do, to do better hash, right? So if we were like to do Casey better hash function, and you're going to type this in anyway. Oh wait, that's that's a different. I see we have that comment. It's so good. So if we have to do better hash function, and the only thing that we're going to do here is do this add, it seems pretty straightforward to actually do the 65599 one, right? So that seems trivial to remember, right? 65599. If that's all it takes to get us, I don't want to say significantly better hash function, but perhaps significantly better hash function, that seems worth typing in, right? I mean, that seems worth typing in. Now, what Pseudonym73 was saying is that using the one for symbols in ELF might be a good idea because we have common strings with numbers at the end, and that'd be a similar case. And so it may be that the one that Pseudonym73 was suggesting might actually be the better one for this case here. But it looked like it was a little harder to remember, potentially, if that makes sense. So I don't know about that part. Like, it'd be kind of hard to remember that ELF function if you were just going to type something in. So what do you think, Pseudonym73? Do you think that this one is good enough? Like, how would you feel if we just went with the 65599 one? You think it's going to be okay? I mean, either way, it's probably okay, but, All right. So we'll just leave that in there, and we'll call that good. Looks like no questions today. It's all quiet. Capping's from, do you have a stream schedule? Yes, actually, if you want to know the stream schedule, there's a couple different ways you can get it, but the easiest way, there's one way is this button tells you the countdown to the next one on handmadehero.org, so that's helpful. The other one is there's the tweet bot. So if you follow this tweet bot, Handmade Hero, on Twitter, then basically it just tweets the schedule all the time. So you can always know when it is. At the beginning of the week, it tweets something that looks like this, so you can just look and see what the whole week schedule is going to be. And then every day, it tells you the time in the morning that the stream will be, and then an hour beforehand, it'll ping with the link in case you want that. It also afterwards will ping out the YouTube video in case you missed the live stream. So it's pretty handy. Pseudonym73, actually, could you humor me and look at the assembly for that hash function, the 655991? I'm curious to know how well it compiles. Uh, but an integer multiply is not going to be that extensive, is it? Expensive, is it? What's the clock cycle on an imul these days? Maybe it still is. I don't know. Actually, you know what I could do that would probably be faster than trying to look it up there? But yes, I will definitely humor you in a second. I just kind of want to satisfy my own curiosity here first. I mean, that's like no cost, pseudonym 73 is. I mean, right? So why? I'm curious to know what you're concerned about. Is actually what now I'm curious. I'm curious about your curiosity. But yes, we'll do it twice. Obviously, this version has optimizations off, so that's not going to be very interesting to you probably. But we'll do that first, and then I'll switch optimizations on, because that's what you're actually going to want to look at, I would assume. So if we go into Handmade Debug, and we take a look at 655, oops, 99, oops, yes, thank you, goodbye. And we set a breakpoint on that line, and run it. What's the problem? There we go. So if we run that guy and take a look at what it did with no optimizations, what did it do? It just issues the imul. So it issues the imul, it does the add, and then it's done. So that's what you would expect, I would think. I don't know how expensive the imul is. To be honest with you, I just don't remember it's not that I don't remember. I just haven't looked recently how expensive an imul actually is, but I have trouble believing it's particularly expensive. If the mul EPI 32 is a throughput 1 instruction, then maybe you've got a little bit of an overhang. What was the latency on that? 5, worst case. And yeah, 5 cycles isn't the best, but at the same time, it ain't horrible, right? So there's that. If I go ahead and allow the optimization stuff to kick in, we haven't done that in a while, but oops. If I go to handmade platform.h, where do we turn off the optimizer? I don't remember. Because we do it, right? Or did we not? So, have we never... let's see, 64-bit build, handmade.cpp, Win32 handmade. Yeah, so we've changed the optimization, right, so that we always build with optimizations on, right? Huh. So what did we do here? I'm super confused. Did we just never went back and did that, but we did smush the code together? All right, to be continued on that one. But for right now, let's go ahead and build with optimizations on and see what happens here. Okay, same basic difference, I would say. Didn't really do anything else. Looks like it's just still issuing an imul and an add. Cubercaleb, what is imul integer multiply? Yes, it is. Imul is just the standard x86 instruction, which got carried forward to x64, which is what we're using here. It's just the standard instruction for multiplying two integer values together. So basically what happens is you put which registers you actually wanted to multiply. And in this case, because we're multiplying by a constant, there's actually a special form. This kind of gets pretty off topic, but so Intel instructions set is it's kind of an interesting instruction set. So the way the Intel instruction set works is it's not like, say, PowerPC or something, where every instruction is a fixed size. Like, you know how we do sometimes on stream, like we'll do like a struct and we'll just have a union and all the different things are in the union. So even though there's multiple types of things, every one is the same size. So it's however big the biggest one is, that's how big each of our things is. And then we just have a union in there that's like the different sizes or whatever. Well, some instruction sets are like that. So for example, PowerPC was like that, where every instruction was the same size. So when you looked at an instruction, you knew that it was exactly the size, and all of the instructions had to fit in whatever that was. You couldn't have an instruction that was longer. Intel is not like that. The way Intel instructions work is it's encoded as a variable number of bytes, and so different bit patterns in each byte tell you whether to read the next byte. So for example, you can see here that this MOVX SX instruction is actually encoded as 3 bytes. It's encoded as OFBE03. But the imul is actually encoded as a lot more bytes. It's 69FF3F000100, right? So it's totally different. Now, you may ask, why is this the case? The answer is because of the way that it got extended over time. If you wanted to be backwards looking and try to be generous to it, you would say that it's because you want to have the ability to have some instructions be longer than others so that you don't waste time spending a lot of bytes encoding a lot of instructions. So it's kind of like a Huffman tree encoding of instructions, right? And you could see that being a very smart way to encode instruction streams for processors. If you don't know what a Huffman tree is, it's basically a way of, it's a compression technique. You can go take a look at it. But point being, Intel's instruction coding is sort of like that. But it's not a particularly well-designed Huffman tree, because instead of having all the instructions you ever might want known ahead of time and then perfectly balancing the Huffman tree to be set up for the frequency of a given instruction translating to how many bytes it takes to encode it, it's actually more like every time they went to extend something, that became another sort of level down the Huffman tree or whatever. And so it's actually not that well designed for compression necessarily. Whatever. What are you going to do? That's legacy. That's just how it goes. So the long and short, that's a very long roundabout way of saying, well, what ends up happening is that you can encode some pretty fancy, ridiculous instructions. So one of the things you can encode, for example, is an imul, where you're going to say that you want to multiply the contents of EDI by some constant that is included in the instruction. So you didn't have to load a constant into a register first and then say imul this register, that register. The instruction itself, these bytes right here, are actually encoding the actual instruction itself, the actual constant itself, right? So the 1003F, that's actually this part right here, right? Of that imul. So the imul's like, oh, imul this register, and then here's a constant that we just stuck right in the instruction, and we're going to multiply, right? And so that's just something you can do when you've got a crazy variable length instruction set architecture like Intel's, is you can just go hog wild. So a lot of times when you look at the documentation for an Intel instruction, it looks very different from the documentation for, say, a PowerPC instruction. Because like a simple, a more straightforward non-variable instruction size architecture typically has instructions that are very simple. It's like, here's the multiply. The first parameter is the register to multiply by. The second parameter is the register to multiply to, and it stores it in that second one, the result. It overwrites that with the result or something, right? Something like that is what you would see documented in like the PowerPC or something like that, usually, right? But if you look at IMUL on an Intel architecture, it's nothing like that. What IMUL looks like on an Intel architecture is like, well, here are the 8,000 ways you might want to run an IMUL. So let me tell you about them, right? And you can see that here, if I pull it up. Here are all of the things that it might be, right? So it's like, oh, did you want like, you know, this times an immediate? Did you want this times memory? Did you want this one? Like each one of these is actually two different ones. That's like register or memory 16. Like there's all kinds of stuff. Like it's a festival, right? So the Intel instruction sets are very like crazy configurable in that way, and like everything is like all these prefix codes where they're like, oh well, if you set the high bit of that, then it means that you'll read the next byte and use that to determine whether or not it's going to be an immediate, and if it is, then it's the first part is the 7 bits of the immediate that you combine with the blah and blah blah blah, and that's honestly that's how the instruction set works. It's a crazy instruction set to work with if you're writing a compiler, because the outputting the instructions is just this funny, like, crazy bit of code that is so much more complicated than what it would look like in like a PowerPC or something. Okay, let's see here. Yeah. X13 Pixels, dude, you inspired me to write a handmade Windows debugger. Are you serious? Because if you are seriously doing that, is there any way that you could make it be callable as like a DLL so that like, you know, we could integrate it into 4Coder or something? Because that would be awesome. I would love a Windows debugger that wasn't Visual Studio. Mojo Bojo, why did you put the delta time of each frame into the input struct? That seemed a bit strange to me while looking through the source code today. Well, I guess I'm not sure I understand your question. Is the question, why do we need to pass the delta time per frame to the game? Or is the question, why was it passed in that structure? Which of those two questions do you actually want to know the answer to? Cuber Caleb, why are the half bytes of the hex value 1003F reversed in the instruction? I can understand the bytes being reversed, but the half bytes. Let me see what you're trying to say. I don't think they are. These are bytes, not half bytes, right? And so this is the 3F, right? This is the 0, 0. This is the 0, 1. Now you can't see the 0, 1 there, but there it is, right? And remember, that's not super unusual because Intel's little endian, right? And what that means is that in memory, the 3F comes first. It actually goes in the bottom of the register. The 0, 0 comes next, it goes next. 0, 1 it comes next, right? If it was big endian, it'd be the other way around. So it's not that unusual for Intel to encode it this way in memory because it is a little endian architecture, so that's how it would be encoded in memory regularly, like for reals, right? And I suspect that this might be a full 32-bit immediate because that is probably part of the IMO. Let me take a look. Sure enough. Check it out. So basically what it's doing here is this is a full 32-bit immediate. And it just happens, so it's actually storing this value in there, right? That's what it's actually storing. And so it's like 3F0000100. That's what it is. So it's like, here's the IMUL 69FF. That's the instructions. That's the like, I want to do an IMUL with an immediate. And you can see here that we're probably doing, let's take a little bit, let's look at the instruction operand encoding here, right? So operand 1, operand 2, operand 3, operand 4 here. So operand 3 is that immediate 32. Operand 2 is one of these like register or memory, and this one is a register. So I'm assuming that in our we're maybe in the one operand form, because it's just EDI, but this form is identical to that used by the mul instruction. Source operand is multiplied by the value in the EAX RAX register 2 operand form. With this form, the destination operand is multiplied by the source operand. The destination operand is a general purpose register, and the source operand is an immediate value, a general purpose register or a memory location. The intermediate product is truncated and stored. So do they have the encoding? I don't know that they do. It probably is just the general encoding. Let's see here. Integer sign multiply opcode F6/5. Let's see here. So I don't actually remember the encoding. I don't remember the decryption, the way to decode how that is. But I'm assuming that that actually has EDI encoded in it. If that makes sense. Quartertron, and you want Intel to ship a unifying ISO for all GPUs. Yeah, I mean, look, man. Just because it's ugly doesn't mean it doesn't work, right? Like, every year, these CPUs still run all the code that was compiled for them, right? Like, code I compiled 10 years ago, if I run it today, the only way it doesn't work is if Windows screwed up the APIs, which they often do, right? But the x64 just works. So as crazy as that sounds, and I admit this is a wacky instruction encoding, you know what? It does the thing I want. It provides an extremely reliable way to build a piece of code and run it forever. It's exactly what I want. So yes, I would love if Intel would just be like, here is the ISO for GPUs. Because if they committed to that and treated it like x60 as just part of x64 from now on, what an amazing world that would usher in. There'd be like no more compatibility problems at all. They'd just be gone overnight, right? And I would trade almost any amount of graphics performance for that, because man, the times that I'm sitting around going, we don't have enough graphics performance, compared to the times I'm sitting around going, I wish any of this stuff ran at all and didn't crash. You know, it's no contest nowadays. Okay, so let's see here. X13 pixels. I'll keep that in mind. Please do. If you have any interest in like making, if you're going to do the work of making the debugging stuff, which is a bunch of work to like parse PDB files, or not really parse them, but read them with the APIs or whatever, and then you know, set breakpoints and get register information out. If you're going to do that work, if you could expose that as a DLL that people could call, or you know, whatever, that would be kind of amazing, because then people could build tools on top of it, and that would be awesome. Mojo Bojo, why was it passed in that structure? It was specifically looking for the delta time variable, and that was the last place it was to be. So the reason that I passed the clock as part of input is because if you think about what the clock is, it's input, right? Like, basically, like, you can think of the things that are coming from the outside. I've got, you know, what I'm tapping on the keyboard, what I'm clicking on the mouse, and that time is passing. So when I need to like hand the game stuff and be like, here's all the information you need to know what happened since last time you did something, the time is just like all of those things, right? It's the interval of time that has elapsed between the two. And then like, these are the key presses that elapsed between the two. These are the mouse clicks that have happened. So I consider that to basically input. Another way to look at it would be, what are the things that you would have to record in order to play back a user's session, right? And again, same thing. I need the keyboard input, the mouse input, and the time, right? So basically, like, it is essentially an input device. The wall clock is an input device. And so that's why I tend to think of them as the same. Mojo Bojo, to add on, since each player has their own input struct, it seems to me like passing it through each one when it's going to be the same for each player seems redundant. That's not, we don't do that. That's not how it works at all. So if you go and look at Handmade platform.h, where that stuff is defined here. You can see in game input that you only pass the DT once, and then like for however many controllers there are is a separate set of inputs. So that we don't do that. There are not separate inputs per person. So yeah. So there you go. All right, I'm gonna go ahead and close this. You know what I should do though? Now that I think about it, probably shouldn't quite close it yet, because we shouldn't probably leave it compiling in O2, because I'll forget and be wondering why our debugging is all squirrely, and then be like, oh, that's why. So let's go ahead and save that off and leave it like that. We're still building, right? Yeah. All right, let's close this down. And that. All right, everyone. Thank you for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along with the series, you can always pre-order the game on handmadehero.org, and it comes with the source code so you can play around with it. So if you want to learn from the stream, that's a great way to do that. And you can do that right here on handmadehero.org. We also have a forum site. You can go to the forum site to find out more about the series, ask questions, and have Martin's Mosaico, I don't really know how to pronounce his last name, answer them, because somehow he seems to know the answer to everything. So before I even see your question, he'll probably answer it with a better answer than I would have given anyway. We have a Patreon page where you can support the video series and other handmade projects. We also have a tweet bot that I mentioned earlier on the stream during the Q&A when someone asked that tells you what the schedule is. And speaking of the schedule, I will be back here for the last stream of the week, Friday stream, 5 p.m. Pacific Daylight Time tomorrow. Hope to see you here for that, when we can do a little work prettying up our debug display. That's about it. Hope to see you guys here tomorrow. Till then, have fun programming, and I'll see you guys on the internet. Take it easy, everyone.